Okay, in this video clip, we're going to show the demo, but what we're looking at right now, it appears to be the south end, and that was what's left of the south end. Kind of weird because I thought that the piece they laid on the ground was a full section, but you're noticing just reinforcement here, non-epoxy coated, not showing green. Heck, maybe they got a different epoxy coating that looks this color. There's the post-tension duct, and we're going to watch for a moment here, and I'll tell you what we're looking at. It's only a minute long, so let me pause that. That's not really the volume, rather mute it. Okay, this is the lower deck. That's the back half of it. On the lower deck, we don't see the transverse post-tensioning cables, which I've mentioned a few times in the drawings that there were supposed to be transverse post-tensioning cables on the lower deck. Well, they were in the design that we see online. I'm going to let them work on this section here. I think you're going to see a forensic unit here, so it appears they, okay, right here. There's the post-tension ducts. That's the cable. That's the configuration they used of the rebar. Again, non-epoxy coated. There's the duct. Put one of the ducts for the upper location. It's there. That might be a duct there also. I'm going to move on. There's your CSI unit. I think this pretty much ends all the good data out of this. Well, the data I can see, you guys might see something else as you keep looking at it. I'm going to let since it's such a short video, it's going to tap out in a second. I'm going to let it play out for you guys.
The bridge now has been in place in its final position, so we're going to be getting ready to dismantle and remove the SPMTs from underneath the bridge back into the staging area. Right after that, we will continue with the demobilization of all the rope leads and detensioning of the 2 bars on top of the bridge, and right after that we will be reopening 8th Street to the...
Okay, take note of 2 things. He says 2 bars, not cables. Also, he says he's going to do it before they open the roadway. So they clearly had safety in mind, and the bars were detentioned before the roadway. So I know people keep talking about the roads was, they were detensioning. Well, it's stated that the detensioning was done already before the roadway was share with you guys about post-tensioning and looking at this member. This cutaway, it's an animation. Imagine this is being post-tensioned. That is, this, you can anchor one end and start pulling on this end. Imagine your hands pushing together. Now imagine a balloon in your hands, and you're trying to push a balloon's in your hand as you try to push it together. What happens to the center of the balloon? It expands out. As this is pushing out, the tension that's created in this column, in this girder, would create forces here and here at the center. More so equally at the center is where you would see this cracking across. I'm sorry, it would be in this direction. The tensioning of these cables create a expansion right here in the middle, there where cracking should exhibit itself. Well, should exhibit itself just as if you were crushing it in a test sample at a lab. It starts in the center. If you could slow it down enough, it starts in the center and bursts out from there. I did not see any cracking on the exterior. You want to see some cracks here in the middle. We aren't seeing any. With that said, testing is typically done across the base, the entire base of the product. This post-tensioning cable put it at the bottom, and I'm going to say it's this guy that was being post-tensioned and not the top one. The top one appears to be the lower third of this post-tension column. As this is being post-tensioning, as again, the center is where it normally fails when you're compressing a product to be tested in a lab. So I would want to look between here and here, between there, somewhere about here, and look for cracking that was initiated across to show that this could have, that this compressing this could have caused a crack across the back half of this that caused a failure. They initiate the failure of this column buckling, and then ultimately the load crushing through the upper deck and buckling and not buckling and deflecting the upper canopy, which then gave a new load path, no longer having the top canopy as the top I-beam. All right, so back down to this one. So as you compress the lower section here, this is not in the center. It's compressing only, only down the bottom, concentrically down the bottom half of this. With that said, it's about 4 inches of cover, as we saw in some of the other images, 4 inches of cover around this duct. So that's what's being compressed. And again, the failure is going to be near the middle. I wish we had some really close-ups of the middle. They were focusing down here intently. I'm guessing the middle would be somewhere about here. I like to see if we could see cracks across the face of that, not this face, the interface, the inside of it, as it was being pushed outward. Tensions create a bowing, or I'm going to call it a bowing effect in the middle, a bursting. It's been said that there's an additional 11 foot added to the north end of the structure, or 11 foot's been added to the north side of the structure, whatever it may be. These plans are also the stamp plans that was shown online with the stamp on it. That show 175 feet. So it was not added as an afterthought. It may have been added, but it was addressed with the engineer's stamp. This is not showing 165, and then we're saying all of a sudden now it's 175. It's 175. So maybe they did ask for an extra 11 foot, addressing the bottom hole that's been shown in the bridge. 8-inch inside diameter drain pipe. That's what you're looking at when you see the bottom pipe at the bottom of the bridge, when you see the superstructure of it. 2 bridges were to be butted together with a 1 3/4 inch diameter post tension bar, typical. It goes across through the both bridge, through the back member. This is where the 2 holes would be. I did not find that. What I did find was rebar in a couple of images sticking out. Perhaps there was they were going to pull the rebar out. Don't ask me how they were going to do that. Then you saw how the bridge sits down on appears to be 2 post tension bars securing it. 2 bridges butt together. There is no connection at the base. There will be a connection at the top. Connection of the top canopy, as you see here, post tension bars 2 going through the center. You see the center there? Well, I'll address this too, but going through the center. As you visualize that, those 2 post tension bars are here. They're below the deck, below the canopy. 1 foot below, 1.0 foot in below. So that's that visual there. This plate here and this plate here are the stops. Visualize there. Going back to this guy, top deck. 1, 2, 6. Here's another one. That would be 3, 4, 5, 6. See, it's going through both bridges. We have 6 members. 1, 2, 3, 4, 5, 6. In the videos, when the images online, we see 2 installed. 1, 2. One of my videos, I think I show these 2 being installed. Clearly, it's 1, 2, and this one's not, is the one not installed. That would be the correction, if you will. This is the bottom deck, the canopy. Again, 16 feet for everyone who says that I keep saying 8. That's because I keep using the half drawing. I apologize for offending you guys. This is 1, 2, 2 showing here. All right. So we also have shop drawings. They're going to deal with this. Interesting. Post-tensioning, there's nothing really too standard on everything. There's a lot of flexibility given to the engineer and to the builder on post-tensioning. All right. So what is really recommended in it, post-tensioning, transverse post-tensioning. And this bottom deck did have a lot of transverse tendon spacing. Transverse tendon spacing, not rebar. In all the demolition, you don't see any transverse. I have not seen any transverse. I've seen all rebar. Here again is the drain at the bottom of the deck. This would be your transverse, 1 inch by 3 inch inside diameter, corrugated post tension of 06 wire. Typical. This had a slope on it, this deck, to allow for water to run to the center and working its way to the drain. As you see the underside of the bridge images, what is that? That track. Well, that's for the future plumbing to go in, the future piping. Didn't need to install it to move the bridge. Okay, that would have been right down the middle. Our failure was here. As the two bridges meet, here's a 175. Is here. Canopy. 1, 2, 3. Now this is very important, this part. C1 is very important, C2 and C3. It goes across into the next bridge when the two bridges are butted together. This was not installed at the time of installation. Worse than that, I believe, and there's my 8-foot. Worse than that is these two were installed. These two positions were filled with cabling. This one was not. But remember, we got C2, C1, C2. This was not installed. Even though I'm saying it was installed, it was not installed. This was because drawings call for that to be the post-tensioning member through both bridges. Of course, an update can happen, but here's the number one thing about it. Here's C1. C3 is a smaller bundle. These two were installed. These two are stronger than the outer guy. These two are installed. What were they installed at? First off, it's in the wrong position as per these drawings, and C3 and C2 should have been installed at this stage, and C2 and C3 would have been split loads. And then when you came back with C1, you would marry it up with C2. So this is like a progression. Stronger bundle, and then the weaker bundle out here. And then on the opposite side, since it's the half, it would be stronger bundle, outer C3 would be the weaker bundle, the least capable bundle, if you will. But they filled these two ports already, and the outer port is open. Okay, take a look at these images. You can pause the video in the next few images that I'm talking over. You can see it's kind of self-explanatory there, that there's some empty pockets, and then I'll show the images to try to verify that, and that's the upper canopy, and try to verify their location. That was without my cluster, my writing into it, so you can see it more clearly. Obviously, you can pause it. The two outside are plastic tubes for the post-tension cables, as far as the drawings go. They're the ones that should have been filled, the two outside ones, and then the center one that we're looking at there would then get the post-tensioning cables going across and through both bridges, both bridge decks, the 99-foot one and this 175-foot one. Yeah, how about that for okay. Again, evaluate this, and you guys can have a little fun and tell me if I'm wrong. Thanks for watching. And yet those two outer ports should have been the ones filled. Bear with me. Hopefully I can jump into this real quickly with the image for you. I want to show you also that they were not grouted. Now I've got about 500 pages of reading. Oh gosh, and I'm up to maybe 200 pages of it now. It's really slow and hard reading to talk about what's expected of the highway department on grouting. Grouting is very important. Grouting must be done in all ducts. There is no exception as of now. As of 200 pages, there is no exception to it. In fact, it's very critical about this grouting, which I've always stated that these are ungrouted duct, and the ungrouted ducts allow the bridge to drop down. Call it this much, drop down this much. You're going to have an impact at that point onto the top cable. You've got wobbling. You've got quite a few things that go on. Now you say wobbling. I'm making that word up. No, that is a post-tensioning word. Wobbling and a few other things, but we do not want that by securing it. When I say we, no one wants it. So you would the grouting here would secure it, secure all the cables in position, and no wobbling, etc., would take place. I think when they compress this top of this node bar at the very top, again, here's the 8 foot, right? So when they compressed right at the 8 foot section, 8 foot intersection, that created loads, by default, create loads pushing to the outside, left and right. It then hit number 1 and number 2. So number 1 and number 2. Number 3 was not in place. I've been going crazy going through these, and I hope you guys can look for them. That looks like a huge group. This looks like the small group. I'm still working on this. So I'm going to load this video up, and you guys could find it and be like, you're wrong, and you can, and I'm definitely going to support you if you can find it. I'm going to say, cool, you found it, thumbs up, and you get the big old love you sign and all that. So this looks like a smaller bundle to me. Correct me if I'm wrong. It looks like the smaller bundle, and that's the larger bundle.